Bismillahirrahmanirrahim. Assalamu alaikum, students.
عليكم السلام ورحمة الله وبركاته دكتور.
So today I will solve some problems of this chapter number 7 and try to finish it as early as possible. So here you can see the problem. A constant force of 15 Newton in the negative y direction acts on a particle as it moves from the origin to the point this one. How much work is done by the given force during this displacement? So in this problem, actually this is the force which is in the negative y direction is given. So force is equal to 15 and this is negative y direction mean minus j direction. Y direction is j direction. And the distance is given in vector form. In vector form, the distance is given in vector form and this is equal to 3i plus 3j minus k. So how much for work? So work will be F dot D. So here you can put the values of 15j dot 3i plus 3j minus k. So here just you will find the j dot j, you know that is equal to 1, other is 0. So we will not solve others. So minus 15 multiplied by this 3, this is equal to minus 45. Minus 45 joule. This is the answer. Okay, in this problem, you can see this is a problem related with the graph. So here in this problem, an object moving along the x-axis is acted upon by a force f of x that varies with position as shown. How much work is done by this force as the object moves from x is equal to 2 to x is equal to 8? So we have to find the area under the graph. So here work done is equal to area under the graph between x is equal to 2 to x is equal to 8. So you can see that this is x is equal to 2 and this is x is equal to 8. From here to here, we will see that you can draw a line here and this is one triangle and this is another triangle. So we will add the area of these one. So first work is equal to area of the triangle is 1 over 2 into base into height. So here base is 6 from 2 to 6 is equal to, you can write 2 minus 6 minus 2 and then from 0 to this 20. This is 20 plus 1 over 2 this area. So this is 6 and this is 8. So you can write that 8 minus 6 and this is minus 10. So this is minus 10. Now you can solve this one easily. This is 6 minus 2 is 4. So 1 over 2 into 4 into 20 plus 1 over 2 into, solve it, this is 2 into minus 10. So this is 2 for 22 is the 40 and minus and 2 to cancel and this is 10 and this answer is 30 joule plus. Maybe it can be negative. That's why he has written the answer of negative 30. But our answer is positive. Okay. After this, now you can see this graph. A body moving along the x-axis is acted upon by a force f of x that varies with x. As shown, how much work is done by this force as the object moves from x is equal to 1 to x is equal to 8. So first we have to search where is x is equal to 1. This is x is equal to 1. Where is x is equal to 8? This is x equal to 8. So we have to find the area under the graph from x is equal to 1 to x is equal to 8. This is our problem. So in this case, you can see, you can draw a line here and make the diagram, make that diagram with whose area you can find easily. So you can find the area up to now here. You can find the area this. So we have this two figure, and this is the third figure, and this is the another figure. Okay. So we have 1, 2, 3, and 4 regions. So in the first region, the work will be from 1 to 4. So this is rectangle. This is rectangle. This is not triangle. This is rectangle. So its area is length into breadth. So 4 minus 1 is 3 into minus 8. Minus 8. And then plus this triangle area. 1 over 2 into base from 4 to 6. 4 to 6 is 2. And then down minus 8. Plus then this triangle. This triangle is 6 to 7. So 6 to 7 mean 1 over 2 into 1 and 4. This is 4, this side. And then plus 1 over, no, this is rectangle again. Okay. So it will be 7 to 8 is 1. Okay. And then the up position is 4. Now you can solve this one easily. Minus 24. Okay. And this is equal to minus 8. And this is equal to 2 plus 2 plus 4. So minus 24 minus 8 plus 6. So this is equal to minus 24 minus 2. If we solve this one, minus 2. So minus 26 joule is the answer. So this is minus 26 joule. So here what you have to do, you have to find the area under the graph, but the graph you will make whose area you can find easily. Okay. Okay, after this, a force acting on an object moving along the x-axis is given by, this is the force, f of x is given 14x minus 3x square, where x is in meter, how much work is done by this force as the object moves from x is equal to minus 1 to x is equal to 2. So if this type of question comes, then you have to find this integration. So integration will be what? Work done is equal to, work will be equal to integral sign from minus 1 to 2 and 14x minus 3x square into dx. So we will find the integration. So first integration will be 14x square over 2 minus 3x cube over 3. And this limit is minus 1 to 2. Now we will solve this one. And this is equal to 7x square minus x cube. This is cancelled. This is cancelled with this one. So minus 1 into 2. Now you can solve it easily. 7. First put this limit, 2. So 2 square minus 2 cube. This is first limit put. Minus. Then put this limit, 7 into minus 1 square minus of minus 1 cube. Now you can solve it easily. Actual problem is here. Otherwise it is easy. So this is 4, 728 minus 8 minus, and this is minus 7. This is not minus 7. This is plus, because minus 1 square is equal to 1. So this is plus 1, and this is minus 1 cube. Minus 1 cube is minus 1. So minus 1 minus plus. So this will be plus 1. So this is equal to 20 minus 7 plus 1, 8. And this is equal to 12 joules. So in this way, you can solve this problem. Okay. After this, now see another problem. And in this problem, you can see a body is placed on an inclined plane. Here, 4 kg block is lowered down a 37-degree incline a distance of 5 meters from point A to point B. So from point A to point B, the distance is 5 meters. A horizontal force F. This is horizontal force, but This is not acting parallel x to x-axis. It is making some angle. Its value is 10, but it is making some angle. So that's why you have to make the components. So this component is what? 10 sine of 37. And this component is 10 cos of 37. Okay, let's see. The kinetic energy of the block at A. So kinetic energy at A is equal to 10 joule and kinetic energy at B is given by 20 joule. This is given. One this value and one this value. How much work is done on the block by the force of friction? By the force of friction, not by the applied force. So by the force of friction. So we have to find the work done by the force of friction. So last time we have seen some formulas. So on those formulas, what we will do? We have this F into D plus work done by frictional force is equal to change in kinetic energy. So kinetic energy change is what? mv F square minus 1 over 2 mv I square. But here problem is this F, because it is not a simple this F. There are many other forces. One is this weight is acting vertically downward. Its a normal reaction is upward, and this is the component of mg, and this direction will be in this way. This is 37 and this component will be mg cos of 37. So what will be the force? Net force. This is in this direction. It is in negative side direction. This is the positive side direction. So what we will do, this is not cos, this is sine 37. So what we will do, we will write the value of this net force. So net force is mg sine of 37 minus 10 cos of 37. This is net force, okay? And multiply by D plus W into F is equal to kinetic energy at point B is 20 joule. This is for final and this is initial. Minus 10. So we will solve this equation and then we will get the answer. So M is given, M is I think 4 kg. This is given 4 kg. Okay. So you can put the values 4 into 9.8 into sine of 37 minus 10 into cos of 37 into t, and d is 5 plus wf is equal to 10. So here you can subtract this factor this side and get the answer. This is the way. So this problem, the problem is what? Problem is the net force. How to find the net force? You can make the components and then find the net force. Okay. After this, if the resultant force acting on a 2 kg mass is 2 kg, mass is 2 kg and is equal to the net, the force is in vector form is 3I plus 4j is given. What is the change in kinetic energy? So change in kinetic energy is actually the work done. You know that work done is equal to delta K. Delta K mean Kf minus Ki. Kf is what? 1 over 2 mvf square minus 1 over 2 mvi square. Mvi square. This is the equation. So we want to find the work done. So we know that delta K change in energy is work done. So work done is what? F dot delta D or delta S or D. So here D is what? Here D is this one. Or delta D is this one. So how you can find the delta D? Delta D is the final point is 11I minus 5j minus 7I minus 8j. This is given. So you can find the delta D, and delta D 11 minus 7 is 4I and minus 5 minus of minus 8 plus 3j. This is delta D. So work done or delta K is equal to this is a force value is what? 3I plus 4j. 3i plus 4j, and then dot of 4i plus 3j. So you can solve this one easily. I dot I 1. So 3 fours are 12. 4 multiplied by 3, 12. J dot J 1. So this is 24 joule. The answer will be 24 joule. Okay. Similarly, you can solve this one easily. So this is the same type of problems. Okay, I solved this one. This is the spring mass system. So in spring mass system, a 10 kg M is equal to 10 kg. This is given on a horizontal frictionless surface to a light spring of force constant. Force constant mean K value 1.2 kilonewton per meter. The block is initially at rest. So block is initially at rest means its initial velocity is 0. When a force P is acting parallel to the surface, when the block is 8 centimeter from the equilibrium position, this is its original position, and when you apply the force in this direction, suppose the block is here. Okay, so it covers a distance of 8 centimeter. So this is its x, and x is equal to 8 over 100, and this is 0.08 meter. Now the question is, it has a speed. Also the speed is given 0.8 meter per second. It means if the speed is given, it means that the spring has both kinetic and potential energy. So what we will do? We need how much work is done by the force. So we need the work done. Here the work done is equal to potential energy plus the kinetic energy. So potential energy of the spring, potential energy doesn't mean that mgh. No, this potential energy is called gravitational potential energy. But here we are studying the kinetic potential energy and of the spring. And this is equal to 1 over 2 kx square plus half mv square is the same one. Now you can put the values and solve it. 1 over 2 into k. K is 1.2 into x. And x is what? This k is not 1.2, it is kilonewton. So you will convert it into 10 raised per 3. And this is now Newton per meter. So here we will write 10 raised to power 3. And x square is what? And x square is 0.08 square plus 1 over 2 into m. And m value is 10. This is 10 kg. And then v square. So v is what? 0.8. 0.8 square. Now you can solve this one and your answer will be 7.04 joules. So this is the problem. So in this problem, actually, two kinds of energies are involved. One is the potential energy of the spring and the second is kinetic energy because he has given the speed of this one. Okay. After this. So this is a little bit a technical question. The same constant force is used to accelerate two carts of the same mass. Suppose we have one mass here and this is m and its mass is m a, one is a and one is mb. So same masses. Okay. Initially at rest on horizontal frictionless track, the force is applied to cart A for twice. This is 2F for twice as long as it is applied to cart B. So this is F. The work done, the force does on A is WA. Here the work is WA. Here the work is WB. Which statement is correct? So we have to find just the statement. So WA mean what? Work done on a body is the change in kinetic energy. Here it is starting initially at rest. It means its initial velocity is 0 because you know that work done is change in kinetic energy, mvf square minus 1 over 2 mvi square. So if vi is 0, then this factor will be 0. So we have only this factor. Okay. So in the first case, the velocity, the force is doubled. So when the force is doubled, the velocity, change in velocity will be doubled. So that's why what we will do, we will write here 2 Vf square. So it is doubled. So what 1 over 2 m into 4 Vf square, and 4 is common, and 1 over 2 mvf square, and this is 4, and this value is what? This value is for mb because it has f. So we can write it B, work done for B, and this is work done for A. So this is the answer. Okay. Similarly, you can solve this one yourself and try to solve it yourself. Okay. This is also easy problem. It is not a difficult problem. Just put the value of the kinetic energy and solve it. Other is nothing in this problem. Just change the mess. Okay, so next time I will solve some more problems of this about the dot product, and then we will start chapter number 8. So I stop here because today you have an exam. I don't want to take more time from. Okay, I stop the lecture.
Thanks, Doctor.
And
And I have a question.
yes,
What's the part of exam? Doctor, if the body is full failing, okay, the acceleration will be always minus g. That's right.
yes, yes, always minus
If
u. Down, yes.
yes, what about it go to up? The
Okay,
ball?
okay, let's see, brother. You can see this slide?
No.
You cannot see. Okay, just wait. I share this one. No, you can see, huh?
Yes, yes.
Okay. Okay, let's see this case because this is a little bit confusing. You know that here the body is moving down or the body is moving up. The direction of G is where? The direction of G is always downward. Either the body is moving up, the direction is downward. Either the body is moving down, the direction of G is downward. Okay. So G value is always negative. But when we solve the problems, at your high school physics, I already explained you. At high school physics, you are taking when the body is moving up, it is actually against the gravity. Against the gravity. So that's why you are taking negative. When it is moving down, it is towards the gravity. So you are taking it plus. Understand? You understand this one?
Yes, yes.
Yeah. Okay. But when we are using this notation minus G to solve the problem, I am saying to solve the problems, then you have to adopt this situation. If the body is moving up, the distance will be positive. The velocity will be positive. If the body is moving down, the distance will be negative and velocity will be negative. Otherwise, when you solve the problems, you should do this job, which you have already studied at your high school physics. But actually, the direction of G is downward. You don't say it is negative. You should say that the direction of G is downward. It is always downward. G itself is a positive quantity, itself positive. But the direction up and down, due to up and down, we take plus and minus. Okay, but it is always downward. So that's why we are taking its negative. But when we use negative, then we have to adopt this thing and this thing. Okay, if you don't remember this one, then solve your problems like this one. The upward is negative and downward is positive.
Okay, thank you, Doctor.
Yeah.
Appreciate.
Okay, thank you. Thank you. Okay, inshallah. See you at 7 o'clock, and inshallah, it will be better for you. Okay, Assalamu alaikum.